Let's look at solving the log equation log base 2 of x plus log base 2 of x plus 4 is equal to 3. Because we have two terms of logs with the same base on the left-hand side, our first step is going to be to combine these two terms together using our properties of logs. Since these logs are being added together, we can combine them together as one single log with a base of 2 and multiply the arguments. So we're going to multiply x times x plus 4. So x times x is x squared, x times 4 is 4x. And this is still equal to 3. We now want to rewrite this log equation in exponential form. So we're going to take our base of 2 and raise it to the power of 3 and set that equal to x squared plus 4x. So 2 to the power of 3 is equal to x squared plus 4x. 2 cubed, 2 times 2 times 2, we have 8 is equal to x squared plus 4x. So subtracting, we have 0 equals x squared plus 4x minus 8. Now we need to look at how to solve this quadratic equation. This is one that cannot be solved by factoring. There are no numbers that multiply to -8 but add to 4. So your choices are to either complete the square, which works out pretty nice on this one, or use your quadratic formula. Let's look at how we could use our quadratic formula. So our value of x would be equal to the opposite of b, so -4 plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 1, times c, which is -8, all divided by 2 times a, which is 2 times 1. Simplifying underneath our radical, we have 16 plus 32, so we have the square root of 48 all over 2. 48, if we look at splitting that up, is equal to 16 times 3. So the square root of 16 is 4. So we can write that as 4 square root of 3 all over 2, and then divide each term in the numerator by 2. So we have -2 plus or minus 2 square root of 3. If we put these into our calculator to get a decimal approximation for each of these, if we put it in with the plus, we get 1.464102. If we put it in with the minus, we get a -5.464102. Remember that the domain of our log function is positive values. You cannot take the log of a negative number. So looking at that very first term, log base 2 of x, it is not possible to plug in something that is negative, so that value is excluded as an extraneous solution, and our solution would be just our one positive value for x. So the solution of log base 2 of x plus log base 2 of x plus 4 equals 3 is just one solution. Its exact value would be -2 plus 2 root 3, or our decimal approximation is 1.464102, rounded to 6 decimal places.